Welcome, everyone, to the LinkedIn Live event, Driving Trust, Balancing Functional Safety in the Era of Software-Defined Vehicle, or SDV. My name is Prashant Tiwari, joining you live from USA, along with Chaitanya from India and Oscar from Germany. And we see that we have a lot of participants joining in to the seminar. Welcome all. Today, we're going to have truly a global audience and global participants. So please announce yourself on the chat where you are from and ask your questions. Good morning to you if you are joining us from USA. Good afternoon if you are from Europe. And we have quite a lot of participants joining us from India, Japan, Asia. So good evening, and thank you so much for joining us today for truly this global perspective from automotive safety experts. Let me first introduce our esteemed panel. On the screen, you have the panelist QR code, so you can join them on LinkedIn and by scanning the QR code. First off, let me introduce Chaitanya. Chaitanya is joining us live from Pune, India. And Chaitanya is founder and CEO of a company called Safe SDV, and also a TUV Level 2 certified functional safety professional. He has worked with many of the large name OEM you can name off, which is Renault, Stellantis, Nissan, BMW, and also an expert in 26262, functional safety. We have worked together for many years in the past. 21448, intended safety, and 29148, which is requirement engineering, and many other qualifications like that. Chaitanya, welcome. Anything I missed about you? You want to introduce yourself?
Yeah. First of all, hello, everyone. And thanks, Prashant, for this brief introduction. I'm more passionate about safe and secure mobility, and definitely I'm looking forward for today's discussion with both of you to deal with this topic of software-defined vehicles and functional safety. How do they live together? Thank you, Prashant. Over to you.
Welcome again, Chaitanya. Next off, we have Dr. Oskar Slatosz joining us from Munich, Germany. Oscar is CEO and founder of his company Validas since 2000. And he's truly one of the pioneer in the field, and also runs a podcast with the title Tool and Library Qualification. Oscar is member of many working group in automotive I'm also part of, and really in the forefront of ISO 26262 and functional safety, and very, very involved in the area. Welcome, Oscar. Anything you want to add about yourself?
Yeah, welcome, Prashant. Thanks for adding me. Yeah, our vision is to make the world a safer place. The mission is to care about the tools and the libraries, and my passion is to answer all questions about safety and security.
Thank you, Oscar, for joining us. Last up is myself, Prashant Tiwari, joining you live from California, USA. I am heavily involved in automotive and aerospace world and passionate about software and safety world. Worked for companies like Volkswagen, Toyota, GE, and I'm a big proponent of using innovation technology to really advance the product, which are far better and safer, and proud to have over 60 granted patents. I did my PhD from Rensselaer Polytechnic Institute, RPI, in USA. And prior to that, master's from Indian Institute of Technology, IIT Delhi. So with that, let me go over the agenda very high level. And Oscar and Chaitanya, feel free to chime in. Our goal today is that you will learn something new from us in regards to software-defined vehicle, functional safety, and that field. We know that it's a pretty broad field, very challenging. A lot of challenges are there. We're going to address those head on, and also want to give you some tools to be successful. Of course, if we cannot address all the questions you have, or some of the things which since this field is broader, you can always reach out to us on LinkedIn and other avenues or so. So this is our goal for today. Chaitanya or Oscar, anything you want to add in regards to what we're going to cover for next 35, 40 minutes?
You're good.
You're good. Yeah.
Okay, wonderful. So let me begin by what is SDV? This question gets asked a lot. And before we give you a perspective of what is SDV, it's really important to get the holistic view of what is the evolution of the vehicle. Now, on the screen, I have a visual of it is showing the vehicle evolution. I got it from my friends from SBD Automotive. They have classified the vehicle evolution into 4 stages when you look at bottom to top. So shout out to Alex Euler and David Abdelmaseh for sharing this. If you focus at the bottom, which is vehicle 1.0, and it says functional. So in the 1960 or prior era, the focus was for the vehicle to just barely get it functioning from the driving standpoint. And it had some software, very, very basic software for fuel injection and other aspect, but it did not have more than that. Then we come into vehicle 2.0 era, 1970s, 80s, where IVI, basic infotainment, music systems started to creep into the vehicle. So digital life, vehicles start to see. Now, majority of vehicle, 90%, which we see currently on the road are in the vehicle 3.0 era. They have some update capability, but not fully software defined, because a lot of e-architecture and other complexity gotten into the vehicle, which are very distributed world. But vehicles do have a lot of software, the current vehicle which is driving on the road, which is vehicle 3.0. Then finally, the vehicle 4.0 at the right at the top are the software-defined vehicle, and we have labeled it as true SDV, where the software and the hardware is decoupled so that majority of features and functions which I am talking here is more about driver experience, user behavior, and user preferences are driven and governed by modifying the software. So with that background, let me give you a very high level definition, which I often use. And an SDV is a vehicle whose features, functions, and performance are controlled by software and decoupled from hardware. What does this really mean? So if you look at the chart or the picture, which I got from my friends at Bosch Mobility, so shout out to Achim Nonnenmacher and Dirk Slama. So if you look at the bottom right in the middle of the picture, it says start of production. So prior to vehicle 4.0, both the software and the hardware was predefined for the vehicle, customer take possession, and the vehicle software and hardware never get upgraded. It's locked in that. But vehicle 4.0 and going forward, of course, the hardware has to be at the elevated performance level so that the continuous iteration, development, and other deployment can be done via software. So the vehicle does change form, feature, function even after taking possession. And that's where also the vehicle needs to be functionally safe. That's where the complexity comes up, and that's why we are here for the seminar. So with that, I'll pause here. Oscar or Chetan, if you want to add anything in regards to SDV before we move to high-level function safety overview.
I think this is a brief introduction. Yes, good one.
Okay, wonderful. So moving on, what is high-level function safety, Oscar?
Yeah, thanks. So functional safety is a safety which comes and ensures that the function is doing what it should do. So if you come to the next slide, I can say you how this is achieved. So functional safety, meaning the car does what it should do, is achieved in 2 steps. The first step is you measure the risks. How dangerous is the car or the function of the car? So it's on the left side, you see there's a risk analysis, and there are different risk level in different functional safety standards, because there are functional safety standards that describe how to reduce the safety of a dangerous system to an acceptable and reasonable level. This is the idea of functional safety, to make things safe, reasonably safe. We cannot, in the next years, we cannot avoid any car incidents, or we can avoid many car incidents, but we cannot reduce them to 0. So there will be a reasonable and acceptable level of incidents, and we just need to determine how dangerous is something. And if you have a brake which is defined by the software, or even the autonomous driving, full self-driving, whatever, then things can be very dangerous. And this is done with the so-called hazard and risk analysis. So you measure the risk. And ASIL-D is the most dangerous thing, like self-driving or self-braking or automatic braking, software braking. And ASIL-A is not so critical. Maybe the light is not going, or the sound is not going properly, or something that can distract but still have some safety impact. So these are the different degrees of safety that are measured. And of course, to reduce this high level, or to reduce the risk to a reasonable level, then the safety standards say something about how this is done. And you see there's a table, and most it is done by testing. Here you see different ways of testing. There are code coverage metrics. And for ASIL-D, you have to have MCDC code coverage, which is very difficult to achieve, so you have to test a lot. While for ASIL-A, the statement coverage suffices, which at least says every statement in your program has to be tested, which is also a lot of things to do to reduce, let's say, the software to a reasonable, to reduce the danger from the software to a reasonable level. And that is what is described in a functional safety standard, meaning that ensure that the functions are working as they should. Yeah, of course, you need to document this, and also that you have done it. So you usually do a functional safety plan, meaning describe what you want to do. And these functional safety standards are typically describing a process and requirements on processes. So this is what they do. They say you should do code coverage testing, but they don't tell you how to measure code coverage and how to set up your development environment and things like that. That's something you can still choose, but at the end you have to report the things and show that your system is that you have done everything you need to do. So functional safety is saying at the end you should have a plan which is compliant to ISO 262, and then you should have the evidence, which is called safety case, that you followed this plan. So please go to the next slide. In addition, when you want to make a car safe, then the car is a system that needs to be safe, and this can only be safe, the system, if the system has a good safety concept, meaning, let's say, like 2 different brakes. If one fails, then they have a system, a second one. But also you need to have safe hardware. So normal hardware won't do it. You need to have safety hardware, and of course you need to make the software safe as well. And you also need to make the tools that you use to develop the system safe. And these are also different parts in ISO 262. So the system safety is described in the part 4, and hardware in part 5, and software in part 6, and tools and other things, supporting activities in part 8. So there are different parts of ISO 262 that you need to be compliant with. And compliant means your process has to satisfy the requirements from ISO 262. This is like making a driver's license. So being compliant with it, having done an examination. This is different from being a safe driver, because if you have a driver's license, and in Europe this is pretty hard to get, then it's not a guarantee that you are a safe driver. And in US it's even easier to get a driver's license, but then, hey, you should try the best to become a safe driver. So this safety and standard compliance is sought as a prerequisite to be really safe, and that is how safety is measured. And the I in the ASIL, so ASIL stands Automotive Software Integrity Level, and this integrity means compliance with the standard. And it's not a safety measure. It's that you can say, oh, we are driving better than humans, or we drive 1 million miles without any incident on the highway. So the safety is measured by the degree of compliance with the process requirements from ISO 262. So this is the idea how functional safety is defined and how it's created. Yeah, and now I hand over to Chaitanya to explain you more the safety challenges in the SDV.
Yeah, thanks, Oscar, for a brief introduction. Taking forward from what Prashant explained about SDV and what Oscar explained about functional safety, now we need to see what are typical functional safety challenges in software-defined vehicles. So Prashant, if you could go to please next slide. Now, as we know that software-defined vehicles is mainly about e-architecture updates, about frequent e-architecture shift, about frequent software updates, and so on. We have to really see how does it impact on different levels of ISO 26262. So here our goal is to see what will be impacts at the concept level, part 3 of ISO, system level part 4, software level part 6, safety VNV, which is across all the parts of ISO, and then the safety management part. So at the concept level, basically it is about having advanced redundancy mechanisms in place. As we know that there is shift from domain to zonal central architecture, e-architecture, and which creates over-dependency on few powerful computers. Because of this, what is happening is there is more increased risk of single point failures, because if central computer fails, then entire system can get collapsed. Now, how this can be addressed? There can be different ways to address this. We need to think about new ways of fail-safe or fail-operational designs in terms of functional safety. In terms of redundancy management, we need to come up with new ideas, for example, N-version programming, where we are using different softwares, independent softwares, as a voting mechanism to detect and isolate faults. There is also possibility of monitoring central computer behavior by either zonal computers or by redundant central compute unit. So with this, we can achieve advanced redundancy mechanisms. About Ethernet, Ethernet is preferred networking choice for software-defined vehicles because of its high speed capabilities. But it has inherent problem of determinism or predictability, which goes against functional safety, because for functional safety, we need things to be predictable. And this is where we have evolution of time-sensitive networking, TSN protocol. How it helps is it ensures that there are bounded latency or jitter, time-aware scheduling, and mixed criticality traffic management. Now, coming to system safety level, we all know that service-based architecture is more and more preferred in software-defined vehicles because it gives a lot of flexibility, scalability in terms of operations. But it also, because it is flexible, it is going against functional safety. So what can be done to tie up it with functional safety is to have QoS properties, quality of service attributes, applied to service-based architecture, which will help us to know the limits. And then if the limits are violated, which means that QoS attributes are violated, then automatically we can trigger safe state. Now, safety analysis is another important aspect, which is typically done with the help of FTA, FMEA, and DFA. But when we are doing it for SDV, and that too for service-based architecture, we have to think about extended safety analysis, where we have to, let's say, even the classic analysis of FMEA, DFA, and FTA, we need to evolve with signal-based approach to service-based approach. And we have to think about new ways of safety analysis. For example, FMEA MSR, which is monitoring and system response, extension of FMEA, which is for basically checking the system reactions, and then advanced version of FMEA. STP analysis, which is system theoretic process analysis, which is done mostly in the ADAS domain, autonomous driving, to model the control loops and safety gaps. So we have to think about such advanced safety analysis method. Coming to software level, you can see here the tech stack taken. The image courtesy is from Digital Auto. You can see there are so many layers, starting from hardware, operating system, middleware, and then we have zonal controllers. There is signal to service APIs and so on, and it goes again to cloud further. So when it comes to software, the most important aspect from my point of view is to have qualified operating system, because it is backbone of the SDV. And it's very important to have qualified OS, because if something goes wrong in the OS, entire system will collapse. For qualification of the OS, generally OEMs or tier ones prefer proprietary OS, which are pre-certified up to SLD. A few examples are QNX or Green Hills Integrity. And there are also parallel discussions about qualifying open source OS, which are POSIX based, for example, Linux. It has its own challenges because the qualification is costly and complex. And but even with those constraints, we have found ways how to qualify it, let's say with the frozen configuration or controlled patches. Hypervisor is another important part, which is software layer which controls multiple OS to run together on single processor. And the MPU, memory protection unit, is the normal thing which we are using traditionally. But when we talk about SDV, we need to ensure that MPU is extended in a sense that there are dynamic updates, configuration updates possible for MPU. And also we have to do the integrity check of the MPU after OTA updates. Now talking about OTA strategy for safety release, this is key aspect because software-defined vehicle relies more and more on the over-the-air updates. So how do we ensure safety for OTA during OTA? There is always this temptation to ship half-baked software, and we have to take all the possible care that the safety is either fully included, or it's very important to have safety fully included. Otherwise, there can be cases where driver can go stranded or emergency operation could be halted. About verification and validation, which is crucial part as per ISO 26262, which is spread across all the parts, starting from 3 to 12, let's say. To have V2V covered, we need to think about shift left. This term is also often used in the SDV era. What does it mean? It means that we have to run small iterative testing loops. And we have to shift testing as early as possible so that we detect issues early. And then the fixing of those issues is not involving a lot of cost. And also DevSecOps, which is commonly used term. In terms of safety, how it matters is we need to build safety regression test cases, and then there has to be efforts to run them automatically, so that for each release, we know if the regression is passing or failing, and then accordingly we can decide whether to make release or not, where we include also safety gates. And for the safety management part, which is on the FSM side, we have to ensure how do we make safety case as living document, because we are talking a lot about dynamic nature of SDV. So it cannot go from static one-time approval the way it is happening so far, the safety case part. It has to evolve now from static one-time approval to continuous iterative process for the safety management. To summarize, we need to have stronger redundancy control, as it is mentioned on the top. QoS-driven service-based architecture. Platform shall be qualified, and then testing areas shall be adapted to the SDV dynamic nature, and then the safety argumentation to cover all those aspects. So that's how SDV and safety can be linked together, Prashant.
Thank you, Chaitanya. With that, let's move to the next section, which is about how does the AI and the security consideration are also needs to be kept in mind. So, Chaitanya.
Yeah. This is another important aspect. If you could go to the next slide, please, Prashant. Now, we all know that a lot of AI and ML is getting used nowadays, even outside automotive domains. Outside automotive domain is also not left behind. It is key element in the SDV behavior. And from ISO point of view, there's ISO PAS 8800 standard, which is introduced in 2024, which is specifically focusing on safety and artificial intelligence for road vehicles. And ISO clearly says that it has to be used together with ISO 26262 and SOTIP. It should not be used in isolation. Now, what are the challenges with AI? Okay, first we can see the use cases of AI. As we can imagine that AI is used for perception, prediction, diagnostics, and decision making. The main we have listed here few typical issues of the AI. The first one is missing common sense. So we know that we humans, we have a lot of common sense, and we can easily generalize things from our past experience when we are facing novel or new situation. But in case of ML, machine learning, this common sense is often seen to be lacking, and it cannot decide what it should do when it is facing new situation. So we have to see how to really deal with such cases. The next important point is about data set. All the machine learning and then AI algorithms further depend on the data set quality. Now, when we are talking about safety considerations of the data set, we need to know upfront that the performance and the safety depends mainly on the quality of the training data, the data which is used while training the models. And there we have to ensure that the data set is complete. It is covering all the possible scenarios which we want to deal with, and the quality is governed with the quality standards. And then it is also tested for the robustness. Does it really handle corner cases, labeling requirements, whether the bias is avoided, and how do we update data? Because it can happen that the models which were trained before with the data is no more applicable. For example, we can consider a case where the data were taken from US, and then let's say the models were trained there, and then we are ending up using that in Indian environment. So those data will not be applicable, and we have to really see if it is valid for the use case or not. So we need to always keep this thing in mind, and then it has to be retrained, revalidated, and reapproved. And this is different from ISO 26262, because ISO 26262 doesn't speak about data set, and data set is core part of AI/ML. Explainable behavior is another important thing which we have to stress in case of ML, because all the decisions which ML provides, we need to see how the explainability can be linked to it. There are different ways. For example, we can have feature attribution or rule-based explanations, and it can be also possible that ML is not able to decide something, but the requirement from safety point of view here is that it should clearly expose the confidence level in its output, and then it can be when it doesn't know, so that rest of the system knows that there is less confidence and it can react safely onto it. And when we talk about monitoring AI, we need to think about having non-AI safety supervisor. So there can be simple classic supervisor which can monitor the behavior of the AI, and then it can tell whether AI safety component is really behaving as expected or not, and whether we should trigger safe state. Now, integrating safety and security, as we spoke about ISO PAS 8800, this is very much important to link all those standards together. And the reason being very simple, because we have seen in the recent times that there are cyber attacks which are causing safety risks. And now things are becoming so much dynamic in the SDV era. They are continuously upgradable, and it means automatically that they are vulnerable to cyber attacks. And where it can happen on zonal ECU, it can happen on HPC, it can happen during OTA, or also at the container level. And they cause safety risk, which can result in physical injuries. What could be potential solution here? The potential solution could be we have to come up with unified threat and hazard analysis model. So in safety world, as Oscar was mentioning, we use HARA, and in security we use TARA. So we have to combine both of them to take inputs from each other, and then evolve safety and security models where we have possibility of having safety mechanisms and security controls working together. About the diagnostic part, so far we are using UDS, Unified Diagnostic Service, which is generally great for static or session-based diagnostic. But going forward, there is also need to have diagnostic which is much more dynamic and service-based. So that's where we have SOVD, which is service-oriented vehicle diagnostic. It is standardized API-based way. And how it can help safety is we can have not only the static diagnostic information, but also dynamic diagnostic information from safety. This will help us to improve safety monitoring and the supervision logics in terms of safety health monitoring. Coming to platform part, we have, as per ISO 26262, we have SEOC concept, safety element out of context. We don't need to go in detail. We can discuss about it later if there is need. But the reason here why we want to discuss about platform is we have to think about ways where things can be platformized, for example, at system level or hardware or software level. Examples could be that hardware level, we have microcontroller, PMIC or ASIC, which is hardware SEOC, developed as hardware SEOC, and then it can be used in multiple situations with the same context. And then at the software SEOC, we have all the safety libraries or basic software modules, RTM, Cal stack, as developed as a software SEOC. And the last point, but not the least, everybody is speaking about having software and system, but I think sometimes we tend to underestimate hardware part, because when we speak about SDV, the goal is to have a future-proof hardware. Now, this itself is tricky term. How do we have future-proof hardware, and what are safety consideration to it? So I can give one example. How do we ensure that the hardware which we choose will survive for, let's say, at least 10 upcoming years, and all the safety updates which are going to come for those 10 years will be supported by the hardware? What if there is a scenario where hardware is not capable to satisfy safety requirements? How are we really going to handle that situation? So we need to think about this aspect as well. So to summarize, I think as it is written on the top, also you can see on the image, when we speak about SDV, all the things should go hand in hand, and there is no real chance for them to work in isolation. So that's the summary I would like to highlight. Prashant, over to you. Thanks.
Thank you, Chaitanya. So system safety and software and hardware safety couples together, but what about the tools which are the enablers, and how do you really make them certified and safe as well? Oscar is going to cover that. Oscar, over to you.
Yeah, thank you very much. So the tools are really like a fundament in ISO 262. So if you have unsafe tools, your software will be unsafe, and if unsecure tools, your software will be unsecure. So this is really fundamental, and if we can have a single slide to explain you how this tool confidence is set. First, let's have a look to the tool definition. A tool is something that does not go into the product, meaning it is only used to develop the product. Software and libraries, as I've explained earlier, are part of the product. So let's have a look how the tool confidence is established in the next slide, please.
That's on the screen. Tools and library, or the very
next?
What
about the next? This is just a bit briefer here. So this is the most important slide. It shows a bit similar to what we have seen on the system level. So the tool safety is achieved in the same way as the system safety. So first you analyze the risk, meaning it's called tool classification, and then you reduce the risk if necessary by tool qualification. So these are the terms, and tool classification and tool qualification together is called tool confidence. So you can have two ways of getting tool confidence. One is to use a tool carefully, always look whether it was correct what it did. And the other is to qualify it by testing. Yeah, and this is done using the so-called tool confidence level that describes the amount of tool confidence which is needed. And this is determined in two steps. One, by deciding whether the tool has an impact. If the tool has no impact on the safety of your product, then there is no need to qualify it. And the second step, if the tool has an impact, for example, a testing tool can have an impact to the safety, because if the testing tool would say your software is safe, but the testing tool has a bug or something like that, then it might not be safe. So that's why tools need to be safe as well. And even testing tools can introduce bugs or be a risk for the safety of your product. This is the reason, the right formulation. So determine the tool impact, and testing tools can have an impact. And of course, we have even seen people going into hospital due to compiler bugs. So there was a correct software translated with a broken or buggy compiler into a wrong executable, and then the car driver could not control the car anymore and crashed with a high speed. So this was very dangerous. So tools can be dangerous, and that's why they need to be classified and qualified. And the second step of the classification is what is called a tool error detection. So for example, if you have a code generator that is generating code, yeah, is this critical? Of course, if the generated code would be wrong, yeah, then it's dangerous. But you can also test the generated code as if it was manually written. Well, then you have a high detection probability to detect all errors that the code generator might have, theoretically, with a high probability, because you test the generated code as if it was manually written. And by doing so, you can avoid to qualify the tool, the code generator. So, and this is what is expressed here with this tool detection. So if you are very confident to detect all potential errors, then it's TCL1. But if you have a medium confidence or a low one, then it's TCL2 or 3, and then you end up in selecting one of those qualification methods, and the most used one is the qualification by validation. So this is the idea of tool confidence, and sometimes I ask people what is the best tool confidence level, but tool confidence level 1 means I do not need to qualify the tool. Maybe many people say, oh, this is good, then I don't spend time and money for qualification. But on the other side, tool confidence level 1 means don't trust this tool, find all potential bugs of this tool yourself. So from a developer point of view, I prefer to have qualified tools with TCL3. Nevertheless, this is a bit of dependent also on the tool chain, how the tools are composed. And sometimes it might be good to qualify a tool and sometimes not. But you have to think on this, otherwise your software won't be safe. So I think that is the message of the tool confidence. And now we can come up to the end and have some question and answer. And if you have more questions, feel free to reach me out on LinkedIn and ask also questions you might not be able to ask here or don't want to ask here. So feel free.
Yeah, just one remark, Oscar, on the tool qualification part. What I have observed many times is this activity is taken once the project is awarded and the project is ongoing. From my point of view, this is activity which should be done before choosing the tool, not after choosing. I mean, not after the tools are in place and then people start using it and then everybody says and ask whether the documentation is done or not, which is funny part. It is something which should be done upfront, and then the tool shall be chosen.
Yeah, you're completely right. So ISO 262 says and that the tools are part of the development process. Yeah? And as I said, you need to have a safety plan which is compliant, which includes to have qualified tools. So you should do it upfront. So this is from the theory side, it is part of safety planning. But practical, believe me, I have seen people shortly before the start of production asking us, can you please qualify the compiler, and please ensure you don't find any bug. Otherwise, our delay, we will have a many months of delay in our start of production, just because we forget to qualify the tool. So, and every day of production is many thousands or tens of thousands of euros.
Yeah, we have to improve the safety culture for sure. I mean, it is always this problem. Yes. I have seen people taking safety analysis also as documentation activity, where they don't really come up with any, they don't really question the design. They assume that the design is good, and then there are no findings from safety analysis. I don't understand. I mean, how come? If in the perfect world, I think that is correct, but generally we don't live in perfect world. We should question the design, we should question the concept, and then that's again part of the safety culture. We can go to Q&A, Prashant. Thanks.
Yeah.
You both are extremely right. Coming from the OEM world, what I've seen is that safety is an afterthought, and the safety of tools, which are the enablers, is even further afterthought. But everything has to go together. So with that, it concludes our prepared session. So thank you, Oscar, Chaitanya. So folks who are online, feel free to send your comment as a question. And we're going to move into our question and answer session now with the questions we have heard from people prior to that. And feel free to keep asking. And the things which we cannot address, we will address that eventually. The first question, which I've often seen, and maybe Chaitanya, you can add, you alluded that in your presentation, is that is SDV just means centralized e-architecture?
Okay, so SDV, first of all, as you were explaining, Prashant, it is there is no single definition of SDV. And so e-architecture is one part of it. Even in that part, it's not fully central architecture. There are again different schools of thought. So the most optimum version of it is we are talking about zonal central architecture, where we have 4 zones, let's say, and then 1 or 2 maximum HPCs. But again, to answer to this question, it is not only e-architecture shift, it is also software updates part. It is also managing safety of it. It is also ensuring that we are removing dependency, we are decoupling hardware from software, and so on. So that's how I can answer this.
Absolutely. Oscar, do you want to add anything?
No, this is...
Okay. No, I'll address that as well, because this is something I deal with all the time. People often confuse that there's a 2 paradigm shift happening in the automotive world, especially from the production cars, is that the whole central architecture or e-architecture is changing. But then at the same time, the amount of software going into the car to drive the functionality is also changing. I would say they both are running in parallel, but not the central architecture or centralization of e-architecture is not exactly what software-defined vehicle is. Software-defined vehicle is that you are not shipping a vehicle which is logged in with the hardware and the software together, but you're able to upgrade the functionality even after production. That's what truly a software-defined vehicle is. So we can move on to next questions. Feel free to keep asking your questions. And
I'm not sure, maybe we have a technical problem. I cannot put any questions to the chat. So if you have the same thing, the same problem, then feel free to reach out us via LinkedIn. So then we will answer the questions and directly on LinkedIn. So this is might be a problem here of the platform. But of course, we do have questions and that we can prepare some that we can answer. But I see a question.
Yeah, I do see a question coming from Parthiban. So we can move on to that one. So how do we bring safety to the neural networks? That's a very good question. Chaitanya, maybe you can start. It's related to the AI domain safety.
Yes. Yeah. So as I was explaining there, while explaining AI ML safety consideration, we have to consider different aspects. First, with the ML, there are inherent limitations of the ML with respect to explainability, with respect to determinism, and so on. And when we are talking about AI part of it, then we have to ensure that there are non-AI supervision mechanisms. And as I also explained, we already have we also have ISO PAS 8800 standard, the first version, which is not very mature version because it is released hardly 1 year ago. But we are supposed to take reference of that and to deal with safety qualification of AI ML components, and then using them in SDV space.
Yeah, well, let me add on that. Currently, there is, for embedded AI, there are some requirements, for example, in ISO 8800, this new standard appeared less than a year ago. There are some requirements what needs to be done, but they're not complete. So this is just saying, okay, you should have data annotation, you should validate your data, you should do some concrete steps, and of course, all involved with the tools. So using embedded AI in the product is something which is, I would say, not so mature from the safety standards, but using AI as a tool, let's say, to develop, to program software, other things, there we can apply tool confidence, and we know how to make AI safe. So we have to have a high detection of all potential errors that the AI can make. So if the AI does a wrong coding, and it can be omit a requirement or have a syntax error or whatever, for all those kind of potential errors of the AI agent, we have to have a high detection mechanism in place. And then we can use AI with the required confidence. And of course, this needs to be documented as well.
Yeah. I mean, I just want to conclude this question because this is very broad, and when we can address that offline as well. When people say AI and neural network, it's a very wide field from supervised, unsupervised, and various different forms of that, and especially how the LLMs and others are creeping in. So it's highly non-deterministic by nature. Now, how do you really bring in regards to some kind of determinism and fail-safe mechanism using ISO standards and other things, which they were not designed originally from these methods? This is an evolving field, and we are working. All three of us are right in the middle of that, and happy to answer that more questions offline. With that, I'm going to move to another question which came earlier. This is in regards to the tools. I believe, Oscar, you already covered that. The question often gets asked is, as we said, it's an afterthought, and this further afterthought to certify the tools and all. What is the best tool confidence level to begin with when you are on a production program? I
partially answered the question indeed. Tool confidence level 1 means don't trust this tool, no need to qualify it. And TCL 3 means I can trust the tool and I have to qualify it. And the true answer, it depends, because if you have to test your software anyhow, as in the example of a code generator, and then it might be better to not qualify the code generator and argue, well, we test the software anyhow. But I know BMW, and this has been published, for example, they're saving millions because they qualify the code generator that they do not need to test on the target, because testing on the model for them is much cheaper. So it always depends on the balance between what you spend for not qualifying the tool, as let's say adding these mitigations, these workarounds to not qualify the tool, and the effort and you would spend for qualifying the tool. And of course, also if you have only 1, 2, 3 users, then it is maybe easier and cheaper not to qualify the tool and have them work carefully. But if you have dozens and hundreds and thousands of users, as in the case of BMW, then it makes sense for them to qualify the code generator. And by the way, we do this since 20 years now for them.
Yes, you are really an expert in that. So thank you so much.
I can also add something to
please.
this. Okay, not exactly answer to the question, but the importance of tool qualification is also increasing because we are moving to a lot of dynamic stuff. We have DevSecOps, where we have continuous integration framework, and we are heavily dependent on results which are coming from continuous integration framework to deliver something which is safety compliant. So which automatically means that the tool chain has to be qualified. We should be 100% sure that tool chain is not malfunctioning. It is not giving false positives or the results which we cannot rely upon. And also we are going towards digital twin and virtualization topics. Where we are talking about having digital replica of the controller and the things in the cloud. Now, how much it is trustworthy is again tool qualification domain problem. So it is something which we have to focus more and more in coming days.
Yeah, I always like to say I'm an expert in tool qualification and avoidance of tool qualification, because, hey, when you look to a tool chain and see how tools interact and, let's say, classify the tools in the tool chain, then we end up in very good results. And typically, the continuous integration, we end up in finding arguments and being sure that this can be tool confidence level 1. So we have some experience in that, and not everything needs to be qualified, but everything needs to be exactly analyzed. And I always say the better you do the analysis, the more money you can save in the qualification.
Absolutely. So we're actually coming to the end, but I do want to take up one question which just came in from Ray, very good one. It says, for SDV, cybersecurity is becoming a functional safety problem when an attack path can directly influence perception, localization. How does a sufficient cybersecurity actually cost today? And this question is more about how do we do cybersecurity and the functional safety in conjunction together, because they both are interrelated, intertwined. So maybe Chaitanya, you can start, Oscar can, and then I can also chime in.
Yeah. As I explained also in the presentation earlier, we should stop looking at those different standards in isolation. It is not going to work now. We need to bring cybersecurity. We need to have functional safety, SOTIF, AI/ML safety. All have to work in hand. Because I have seen this many times, even in large OEMs, they have different cybersecurity manager, functional safety manager. Each, they don't know what is happening. First of all, safety is considered as a different island. Cybersecurity is yet another island. They don't know what is happening within each other domain, and this is classic problem. So that's where, even at the organization level, at OEM tier 1 level, we need to have culture where all these different things are seen together. Their impact analysis and assessment is done together, and then somebody is really joining them and then seeing what the impact is and how to address them together. That's key here.
Absolutely, you said it very right. I don't have anything else to add besides what Chaitanya said. Oscar, do you have?
The second part of the question addresses the overhead that is introduced maybe for encryption and how much will it cost you. So it depends, of course, what you spend and how long it take, which algorithms you have for encryption. And if AI can help here, yes or no? Yeah, in network management, AI can be helpful. I haven't heard about this being deployed within cars. And in general, when you want to use AI, you have to use it in a safe way, and always think about it can hallucinate, and how would you detect this? So from the safety, you don't need to have 99%, you need to have 100%, and therefore just trusting AI is not the solution.
Absolutely, you put it very well. So with that, we are almost at the time now. So what I want to say is that some of the questions, since we will be, you can revisit this video. If there are questions, please add to the comments, and we'll make every effort to address that and on the chat. At the conclusion, I want to show the profile of Chaitanya, Oscar, and myself one more time, so that you can reach out to us on LinkedIn, or else as a comment to this live seminar, which is going to be on both, which is currently on both YouTube and LinkedIn. And we will make every effort to answer all of your questions. So with that, I want to say that, Oscar or Chaitanya, anything else you want to add in conclusion?
Yeah, feel free to connect and continue to ask questions. So that's safety is always a common thing where we work together, and that's good to have.
Yeah, Chaitanya.
I think all of us, we want to have safe and secure mobility solutions. So as Oscar is saying, we are always improving in terms of safety or security, and with these new standards. So we can keep in touch, and you can feel free to ask questions, and we'll be happy to answer.
Absolutely, absolutely.
So thank you very much for participation, and bye-bye.
Thank you so much. And since we had basically, this is going to be live on both LinkedIn and YouTube. So once again, for the global audience, thank you, danke schön, dhanyavad, arigato gozaimashita, and please connect to us and reach us online on LinkedIn. We're going to end this stream now. Thank you so much.
Thank you. Have a good day. Bye-bye.
Bye-bye.